Welcome friends. Now this is our last part of the distribution network. As mentioned previously, in this part we shall briefly demonstrate about the AC distribution or distribution network with AC excitation. Now what is the difference between AC and DC distribution? Now in the DC distribution we have only resistances, but in AC distribution we have impedance, that is the resistance, along with we have a reactive part. And since there is a reactive part added, so there should be a definite power factor comes in the picture. So with all this, we shall briefly demonstrate a problem how the calculation of AC distribution is carried out. So let me straight going to the problem. Let us say a single phase distributor AB, let me draw. This is the AC distributor. Let me mark, this is A, this is B. This is 1 kilometer long, 1 kilometer or 1000 meter long. Has a resistance and reactance per conductor of this 0.1 ohm and 0.15 ohm. So Z of this feeder is 0.1 plus J 0.15. Now at the far end, that means at this point, it is said that VB is equal to 200 volt. VB is equal to 200 volt and the current is at tapping at 100 ampere at a 0.8 power factor lagging. So this at power factor is equal to 0.8 lagging. So that means you can directly say that is the IB, which is equal to 100 at an angle of minus 36.9 degree. Why? Because power factor, you know, cos phi is 0.8. So if you take the reverse, cos inverse, so you will get it is as 36.9 degree. Now why this negative sign? Because it is lagging. Negative sign is due to the lagging. Or in some other words, you can say this IB is equal to 100 0.8 minus J 0.6, which is equal to 80 minus J 60 ampere. Now this is cos phi and this is sin phi. Cos phi is the power factor and sin phi is the 1 minus cos square phi. And this minus is due to the lagging power factor. So this is coming, where from it is coming? Answer to this, it is actually this expression. This expression, right, 100 cos 36.9 minus J sin 36.9. So cos 36.9 0.8 and sin 36.9 value 0.6. So from there you will get IB is equal to 80 minus J60 and VB is equal to VB is equal to 200 at an angle 0 volt, because we treat this one as a reference phasor. And the current now, okay. So at the midpoint M, let me mark another point M. Let me say this point is M. So at the midpoint, so this length is 500 meter. So another load is being tapped. Let us say this point is P. At midpoint M of the distributor, a current of 100 ampere is tapped at 0.6 lagging. So this IP is again, we can say 100 ampere at 0.6 power PF lagging. So that means we can say IP is equal to 100 at an angle of 53.1 degree minus 53.1 degree. Why? Because cos phi is equal to 0.6. Here power factor is set 0.6. So if you evaluate phi is equal to cos inverse 0.6, so it will giving you a value of 53.1 degree. So IP you can straight away write 100 cos 53.1 minus j sin 53.1, which is equal to 100.6 minus j 0.8, that is equal to 60 minus j 80 ampere. Now you need to determine two things, supply and voltage. That means you need to determine VA, and angle between VA and VB, angle between VA and VE. These two you need to determine. Now let me clearly mention here that now what is the question is, what is the current IAP? What is the current IAP? It is basically IAP. From the diagram you can say IAP is nothing but the summation of IP and IB, because this current is nothing but this IPB is nothing but IB. So IAP is nothing but IP plus IB. So what is IP? 60 minus J80. And what is IB? IB is 80 minus J60. So altogether it will be 140 minus J140 ampere. So now what will be VAB? So the voltage drop in this section. So voltage drop along AB. So it will be VAB. We can write VAB is equal to, your first part is this IAP into ZAP. So it will be IAP into ZAP. This is the first part. And the second part is IPB multiplied with ZPB. Now what is IAP? IAP is this current. It should be 140 minus J140. Now what is ZAP? Now you see this Z feeder is nothing but it is the value of ZAB. Now ZAP is just the half. ZAP or ZPB is just the half of ZAB because it is the midpoint. So you can write it is equal to 0.1 plus J0.15. It's just the half. Now let us going for this expression. What is IPB? IPB is this value. Where is IPB? IPB is this value. 80 minus J is 60. So it is 80 minus J60 multiplied with this expression 0.1 plus J.15 by 2. So now if you solve this, altogether you will have this one as 52 plus J13 divided by 2, which is equal to 26 plus J 6.5 volt. That is the drop in the length or along the length of the AB conductor. So what is VA? What is supply voltage at point A? So VA should be is equal to, it is 200 volt plus this value 26 plus J 6.5, which is equal to 226 plus J 6.5 volt. So if you convert this into polar form, you will get 226.1 at an angle of 1.65 degree. So this is the first answer, VA. This is the first answer. What is the supply end voltage? That is VA. Now the next part, what is the angle between VA and VB? What is the angle between VA and VB? Let me check. Yes, supply end voltage and the phase angle between VA and VB. The second part is the phase angle between VA and VB. So VA is, the angle of VA is 1.65 degree and the angle of VB is 0. Why? Because we consider this one as a reference phasor. So the difference, that the phi, that is the difference, phase angle difference is 1.65 degree. And this angle is also called load angle. This angle is also called load angle, the difference between supply and load. Okay, this is the second answer. This is the second answer. This is the 1.65 degree. So now the one significant interesting thing you should note or you should notice here is that since this problem deals with AC excitation, though every calculation here is the phasor calculation, it's not simply algebraic calculation. Every calculation here is the phasor calculation. So that means if you add two phasors, it is not a simple algebraic addition, it is a phasor addition. So you need to consider the angle part as well. Okay, so with this we cover most of the portions of DC distribution. We started with a brief introduction of distribution system and the comparison between distribution and transmission network. Thereafter, we have started with DC distribution network with single end feeding and double end feeding. After having done that, we have covered the DC distribution with uniform loading, both single end feeding and double end feeding, and at the last we have demonstrated a brief example of AC distribution, how problems are been there, the primary difference between DC distribution and AC distribution is that DC distribution only having resistance, but AC distribution is having resistance and inductance. That is why we have to consider the angle part and as well as the power factor of the load. So with this we have ended, or we are ending the distribution portion. In the next section we have left with one final topic, which is the mechanical design of the transmission line. That is the sag of the transmission line and the tension of the transmission line, and that chapter we shall discuss in the next few sections. So thank you. We are ending this lecture, or this part of the lecture here, or this module of the lecture here. Thank you.